So now we have reached the core of what we were trying to do. It isn't very much of a game so far, and it isn't very fun either. So let's expand upon the idea a little bit and see what we can accomplish. The first thing we might want to do is create a spawner. A spawner is something that spawns objects. So for example, we have this one static object placed in the world already when we start, but you might want to have it dynamically spawn more objects in runtime while you're playing. So let's get and do that. We'll create a new blueprint of the type actor. Call it BP pickup spawner. We open that one up. Now, to spawn objects is fairly straightforward. All you have to do is, if you go to the event graph, and let's remove some of these events, and let's say we have a similar approach to when we were scanning our drop-off area. We have a timer. So we'll set timer by event. We'll say every 3 seconds. Create a custom event. Call this spawn pickup. We'll hook it up. Promote a variable. We'll call it time between spawns. And we'll set this to looping. There. Now we have our events which will actually make something recur every now and then. So we just type in spawn actor from class. This gives us a template of what a class has as inputs. This will change. We get to choose a class here to spawn, and depending on which class we choose, we get different input parameters to have here. And we'll get a little bit more into that further along the road. But for now, all we need to do is choose BP pickup. And you'll see we have a spawn transform, we have a collision handling override, and that's basically it. So if we were to compile now, it would complain because we don't have a transform set. If we are to split the transform struct, you can see that it has a transform for location, rotation and scale, and that's basically what it wants. It wants to know where in the world should I create this object, what kind of rotation should this object have when I spawn it there, and what kind of scale would it have when I place it there. So by default it has 1, 1, 1, which is the normal scale. It has the rotation of 0, 0, 0, which is no rotation at all, and it has the transform of 0, 0, 0, which means in the center of the universe, almost the center of the 3D space. These two are usually fine for most cases. The transform is not that helpful. This is a spawner which we imagine that we can place somewhere in the world, so we would likely want to have the spawner's location as the location where these objects actually appear. So let's do that. We will get self, and then we will get actor location, so the location of this spawner, and we'll put that in as the transform location. Compile, save, it seems happy about that. So if we were to bring a spawner now into the world, which is unfortunately only represented by this little white sphere, but it'll have to do, and then click play. Spawner should be somewhere here, and there we see it spawns a cube and places it into the world, and every 3 seconds a new cube will be spawned until it reaches its max height here, and then who knows what will do it. It might explode, fly all over the place. Yeah, it's doing some funky stuff now. It's having fun. Who am I to deprive it of fun? Yeah, anyway, so we can still pick up these objects, place them in the volume, pick up another object, place it in a volume. So we have added just a tiny little thing, but already it's much more fun, if nothing else, to see them explode and fly all over the place. Now might be the time to actually conceptualize a little bit about what makes sense for this kind of game, right? So we have something that spawns cubes for us. We can pick them up, we can place them in a drop-off area. That's all good and fine. But why would boxes appear out of nowhere? Can we somehow make that more logical, or at least reasonable enough that the player would buy into it, even like by fantasy or sci-fi standards? Well, we could make, for example, a machine that is constantly producing items like packages or something of that nature, and we're picking up these boxes from a conveyor belt. So let's look closer at that. Creating the conveyor belt is going to be similar to what we have done before. We create a blueprint class of type actor. We'll call it BP conveyor belt. Unsure about the spelling here. It'll be fine. It'll work regardless of poor spelling. Conveyor belt. Let's go with that. And we want to start off with a static mesh to have a visual representation again. Belt mesh. We put in a cube. We scale it around a little bit, flatten it, maybe make it a bit narrower. Whoops. Maybe something like that. We can alter this later, of course. Then we want to add a arrow. The reason for this is the arrow will show us, give us a representation in the world for which direction. That's not what I wanted to do. I want to have the arrow attached to the root node, and then we'll drag the arrow up only. There. So this will show us how, which direction the conveyor belt will be, and if we place it in the world, it will make it easier that way. In addition to that, we should need a volume. So box collision, and whoa, we don't need to scale it that much, but we want to cover the whole area, which, well, that's not what I wanted to do either. The whole area which is supposed to be the conveyor. Just so, let's move the box to be actually under the belt mesh in the hierarchy, so it follows that one. We want to scale it so that it covers the whole static mesh, so that anything that is placed upon it is actually going to be affected by the logic that we will be adding, which will be basically moving an object slightly. Something like that should probably be fine. It's probably better actually if we have it above rather than below, and it's actually probably better that we have it further. Come on, there we go. So that things don't float off when they're in the air and get affected. That wouldn't look nice. So something like that will probably do for what we need. Now then, to the actual logic. In this situation, we talked about how we want to avoid a tick. I am unsure if we can avoid it in this instance. So I guess we will actually use that one for now, and then see if we can come back to it later and maybe make it in a better way. But for now, let's see what we can do with tick. So what we want to do is, again, we have a, whoa, I renamed the volume. The volume should be named belt volume or something like that, right? And we'll drag that in here. And what we want to do is similar like before. We want to get our overlapping actors. We want to move our BP pickups, and we want to loop on them so that all the pickups that are on the conveyor belt are moved. And for each of these we want to world offset. No. Okay, let's see what happens with this one. I don't think this will work. Let's remove this one. This has to do with the issues that we had earlier about the actor itself is going to be from a different position than the physics objects, because the physics objects can actually be detached sort of in relation. So what we need to do is actually get the pickup mesh. Okay. Right, we're getting an array of actors here, which means that it is of the class actors, even though we're filtering, which means that we actually need to cast each object as well to pickup, so that it actually is aware that it has a pickup mesh. There we go. And that one. There, that looks better. So we want to add an offset on this particular mesh, which basically means just we're gonna move it in a direction. So what we need to do is we have our conveyor belt. That is not what I wanted to do. So we type in self. We get our forward vector. Should be the same as the arrow. And this is the direction that we want to move in. But we want to move a direction that's relative to the amount of time that has gone since the last time we came here. Now we have to delve a little bit further into how ticks work. Ticks, as we have said many times before, is something that's played once every frame, which means that if you have a computer that's running at 120 FPS, then you're gonna get the tick execute 120 times. If you have a computer that runs of 30 FPS, you're gonna have it execute 30 times per second. So in olden times, when you had logic that was related to tick, it would mean that a game that ran on a better CPU, had a higher frequency on the CPU, would allow that game to run faster, meaning that if you were normally meant to play it on a slow computer, if you played it on a fast computer, all of a sudden you would run much faster in that game. Like literally run faster. And all the animations would play faster, everything like that. So that's mistakes that were available in the early days of game development. The way it's counteracted nowadays is that we get an event tick with a delta seconds, meaning that if you have a computer that runs at 30 frames per second, then it would come in here and say that, well, 1 divided by 30, which is the frames per second, is the amount of time that has occurred since last time I was here. And then you use these delta seconds to compensate, making sure that you get a fluid movement in speed, for example. So you would never actually run when you're trying to walk. You're always going to be walking regardless of how fast or how slow the computer is, because the amount of time that has passed will help you compensate for that. This also means that if you get a frame dip or a frame increase at a certain point of time, your character is still gonna move fairly consistently because the amount of delta seconds have changed in between those ticks as well. But this means that delta seconds is actually going to be dictating how much we are moving things. So we're going to type in multiply and take a float times float, and then we're going to promote this variable here. We're going to say, since I can't spell conveyor, we're going to say belt speed. The belt speed is what's going to be determining how fast we move them. So this is difficult to say what kind of a speed would be good or bad. It's something that you will have to try out and see what feels right, basically, because it's not easy to make an assessment of what delta seconds will be times the amount of speed you need to have and stuff like that. So for our purposes, let's try with 500 and see where that leaves us. That's 5,000. That's not me typing 500 at all. Anyway, so now we have our potential speed or change that we want to have. We want to multiply our direction with the speed. Let's see if we can clean this up a little bit. It looks a little bit better. So the direction times the speed will give us an offset for us to give this object. Event tick, that's probably fine. Let's compile and save. So this means if we were to bring in the conveyor belt into the world, again I'm making very small objects apparently, so we'll scale this one up a little bit. Let's say so. Let's try to position this one so it's underneath where our spawner is to see if it works when they come into the world. Something like that maybe. Not entirely sure, but it looks like it should be okay. Let's give it a try. There's our first box and it's moving. Although it is jumping a bit, you can see that it's actually leaving the volume when it's bouncing, which means that it will stop moving for a bit. So let's change that. We'll go to the BP conveyor belt, we'll find our volume, that's the volume, change to scaling, and we'll scale it up a bit, maybe so. That should hopefully be good enough, something like that. Let's try it again, see if it's better. Well, there's some room for fine-tunement here, that is for sure. But it will do for now, because this is not likely what we will be doing later on, but you can always tweak this to your heart's content. Let us continue by adding a not a goal, but sort of a condition to lose. We'll be adding a timer, so we can determine when the timer has run out, then the game is over, and then while you are playing you can earn more time by doing different things. So we'll start off by making a new blueprint class. And since this is a system that's not belonging to one of the blueprints we've already collected or created, and it's not really something that fits in the first person character but rather in the game itself, what we're going to do is we're going to open up this all classes, and then we're going to search for state, and we're going to make a parent, we're going to select the parent class game state base. Make sure it's the game state base and not any of the others. We'll call this BP game state. Then we'll enter that blueprint. So we're gonna be using an event dispatcher to communicate this information that we have here. So we're gonna be needing a few things first. Let's create a variable called time remaining. And then we change the type to, let's say, float. And then another variable we'll call max time remaining. And this is to denote which is the highest value the time can actually go up to. We will remove the tick, we will compile and save, and we'll set a value of, let's say, 100 on time remaining and 100 on time max, just to have something in the start. Then we can change this later on. And then we want to create a timer that ticks. So we'll type in timer and begin play, set timer by event. Let's create another variable for this called time decrease interval. So this is how often the loop will be called, and we'll do it looping. Then we'll create another custom event that will be called when this timer is executed. We'll call this event decrease remaining time, and we'll connect the red pin to that one. So this function, this event will be called by the timer at this interval to reduce the time that we have remaining. But let's make a support event here. So another custom event we'll call change remaining time, which will have an input float variable of time change, we'll call that input. So this is the actual event we want to have all collective changes to time calling. What we will be doing is we want to take the time remaining and then add with a plus sign, float plus float, the time change that gets entered into this function, this event. Then after we have done that, we want to set the time remaining to the value that we now have added. Then, to make sure that we are not exceeding our max time remaining, the highest cap that we are allowing time to go up to, we will use a clamp of the type float. And this will get the value that we have just added here, and as a minimum we will have 0, and as a maximum we will have our max. There we go. And then once this is done, we want to dispatch an event. So we will create a new event dispatcher. We'll call this time updated. That's not correct. Updated. That is correct. It looks wrong. Anyway, that is fine. Okay. So this event is what we want to dispatch once we have done any kind of change to the time, so that anybody who's interested in the time can get that information. So we will be changing our input on our time updated, and we'll be adding a float of new time remaining. So this is the information we will be sending through the event. So now we'll call time updated. There we go. And with that value, also we need to, let's do this. We are actually setting the value of the time before we're actually clamping it, which means that we could potentially be setting this to a much higher value than max, and then we will be sending a different value. What we want to do is the other way around. We first clamp it, and then we send that into our actual new value, and then we send that value to the event. There we go. So the player is reasonably one who wants to know about the timer then. And we can make an event to keep track of this. So what we need to do is, let's type in begin play. That's this event. And we have a bunch of stuff going on here. Let's see if we can clean this up a little bit. VR gun, mesh. This seems to be mostly... Let's check in the viewport. Okay, so the VR gun is the one that we can get rid of then. If we go back to the graph, so we'll get rid of this one, we'll get rid of this one, and this. We'll keep this one as it is for now. We don't really care too much about it for now. Afterwards here we want to get game state. Since we created a new game state and that's where our information is, we need to cast this to BP game state. Now that the information is available there, we have a reference to it now, and we can say time updated, and we can bind an event. Compile and save. We get an error because it doesn't have the event here. We'll drag off from the event backwards, and we click add custom event from here. Doing it this way will allow you to immediately get the signature, meaning the input variable from the event dispatcher that we created earlier. So we'll call this time has been updated. So that's the event that will be called when this happens. And what we want to do then is, for now, we want to print a message saying whatever is the time left. This is just us debugging this for now. So let's try it out. Nothing seems to be happening. It's only scanning like before. So we'll quit back out. And the reason for this is we have created a game state, but we're not actually using the game state. So if you go to project settings, you have under engine and up here on the project, maps and modes. You have something called the default game mode with its default settings, and then other than that you also have here under world settings, you have a game mode override, so you can per level basis override the game states or the characters or pawns or anything that you want here, and here you can decide what your default is going to be if you don't change a lot between your different levels that you create. So for us, we can go here and find the game state class, and we can replace it with our BP game state and close down. It will be saved automatically. And let's play again. And it's still working. Okay, let's troubleshoot. So let's jump back into our game state. And okay, we missed this part. We're calling the decrease remaining time, but we're not actually calling the function or the event that is actually making the change. So type in change remaining time, which is this event down here, and then we want to send in the change that we want to have here. So we have set a time decrease interval here. It's currently at 0. Let's set that to 1 just for our purposes right now. You could either have it at 1 or you could have it at -1, depending on your preference. I prefer to do it this way, so I have an actual value that's like absolute, then I do a multiplication afterwards if I want to send a value that's negative. So what we're doing here is we're multiplying the decrease interval value with -1 to make sure that we're actually decreasing, because this change takes in a positive or a negative value, and whatever it gets in here it will add. So if you send in a negative value here, you're gonna get, for example, 100 minus 1, because minus overrides plus, or you can send in a value of 1 here, and then you'll get 100 plus 1 and get 101, and then clamp it and it will go back to 100. So this should be what we need. Let's try it again. Now you can see that we're having a counter counting down from 100 downwards. Good. Now that we have debugged that the functionality is actually there, let's create a widget to actually display this for the player. So we will right click, go to user interface and widget blueprint. We will call this W underscore, let's call it HUD for now, for heads up display. So this will represent our user interface for now. And for a timer, we could use a progress bar. So we'll make this a bit larger. We will anchor it to the top middle. We will reset the position of X and Y. We will set the alignment to 0.5. And then we can move it slightly downwards, so it's a little bit further from the edge. Let's go to maybe 100. That seems okay. We will then be changing its values here. We can see what it looks like if we change the percent here. So if we were to type 50, actually that's inaccurate. It's saying percent, but it's actually going from 0 to 1. So 0.5 would mean it's half full, which means it would look like this when it's half full. And I guess for a first version that could work just fine. We'll compile and save this. Then we'll go to the event graph and we will do something similar to what we did for the first person character. We will do all of this. Go back to the HUD, paste it here. We will do this on the construct, which is a widget's version of begin play. Then we will create an event for this. Then we'll rename it again so it looks better. Like so. Remove the tick. And we want to update the progress bar now. Let's go back and rename the progress bar. It has a bad name, and let's call it time remaining, like so. And compile and save. We go back again. So we want to set the value for time remaining here depending on the new time. But this part of the code doesn't know what percentage of time this is, so we need to do the same thing that we did before here and get the game state, because we need to find out what is the maximum time. So that we can make a calculation of the time remaining divided by the maximum amount of time, which will give us a percentage of what time is actually remaining. Then I'll clean it up a little bit, like so. Then we go back and check percent is the name of the field. Set percent. Set that value to to the value we get from here. Okay. So now we created a widget that should theoretically update a progress bar depending on how much time we have left. Let's see how that works out. We go to our first person character, and upon creation we can also remove all of this code since this is no longer needed and is in the user interface instead now. And instead we want to create a widget. We want to create a widget of type WHUD. Owning player is not self, it is actually, this is probably player controller at this point. Yeah, that should do okay. So the player controller here gets the widget, and then we need to add it to our viewport so we actually display it. There we go. Let's try this out. We go back to the map and we start playing. So we see that we now have a progress bar that is ticking down along with the time. Now, you might have seen in the beginning when we started playing, it starts off at a value of 50% because this is the default value we had from the HUD itself over here. So what we need to do first is to fix this, is to make sure that we update it properly the first time, because what we have done currently is we have said that whenever the updating of time happens, that is when this part of the code comes and we actually update the time. But in addition to binding this event, we also want to run this just once to make sure that we have the proper time in the beginning. And the problem here is we do not have the new time at that point. We do, however, have the game state, which also keeps track of the time remaining. We can send that directly in. Like so. Now, this should be setting our time to be proper at the first moment of creation, and then every time it updates in some form, we would get updated about it. Let's check it, see if this holds out. Seems to work properly. Good. Let's make sure that we have an actual objective in the game to keep us sort of alive by adding more time by doing a chore. Like every time we add a box, we get some time added to our allotment of time remaining. So let's start off with our BP pickup and add a variable, and we call it time bonus, and we'll make a float out of it. There we go. And we'll set this to, let's say, 5, just so we have a value and so it's clear to see. And then we go to our drop-off area, which is the part where we actually despawn the pickup when we drop it there. And we scan for objects, we print that we're scanning, we get an overlapping, and then we destroy it and everything like that. So before we destroy it, let's make sure that we are actually granted a bonus for having dropped off this pickup. So what we need to do is, again, we need to get game state. And what we're going to do now is, because it's not optimal to keep getting a variable over and over again and then keep casting it, casting especially isn't something that you should be doing willy-nilly all the time. So if you can, at a point like begin play, get this value, cast this value to BP game state and then set this value as a variable. Let's call this game state ref, because it's a reference to a game state. The game state won't be changing during gameplay, so having it done once in the beginning is much better than polling for it repeatedly. Which means that we have game state available to us here, which means we can here say change time remaining, and then we do this. And then we need to add whatever time we get from this object. So if we get, of course, this is an actor. We do not know what bonus time is on an actor. So unfortunately we need to cast this. PP pickup. There we go. And then we'll rearrange this a little bit. Not the one I wanted rearranged, but okay. So you can rearrange your nodes however you want, of course, to make it look fancy for you. I tend to want to have no crossings going behind nodes because it makes it unclear to see what is happening and where stuff is coming from. Anyway, now that we have this, let's give ourselves some more space. We have a pickup, we can get bonus time, and we send this into our change remaining. So now theoretically, every time we dump off an object and it gets scanned, we should be getting its time bonus value added to our remaining time, and then that should also immediately affect our progress bar, because whenever time is altered, it updates and sends an event which is then listened to by our HUD, which will then update it so it keeps in line. So let's try this out and see if it works. So we can see that the time is ticking down. We'll go and pick up a box. There we go. We have a box. We'll look at the progress bar, we drop it, we'll get some time added to it. It seems to be working fine. Good job. Now we should have all the pieces necessary to actually reach a conclusion of the game, actually getting a game over. So let's start adding some functionality to facilitate that. To start off with, our game state keeps track of what kind of timer we have left. And let's have our game state reaching 0 time remaining as our game over. That means we need to call a check here. After we have done all the updating, we can check, is the time remaining equal to, okay, hold on, I need to change my keyboard. Less than equal to 0. So if our time remaining is 0 or below 0, then we have reached our game over state. At that point, we want to inform the player that it has lost, and we want to disable its output. Sorry, its input. So we'll start off with editing our HUD to allow for some communication telling the player that it has lost. Let's add a few buttons, and let's add some text. We'll have the text say game over. We'll anchor it to the middle. We will reset X and Y. We'll set alignment to 0.5. 0.5. We will raise it up a little bit, maybe 200 pixels. We can change. Let's go make the button. Let's align that one to middle as well. Reset X and Y. We will also align this one 0.5 so it's nice in the middle. And let's raise this one up maybe 100. We'll make it a little bit larger, maybe 200. Maybe something like that. Then we'll do something similar for this button. We will reset the position, 0.5 in alignment X, 0.5 in Y. We will push this button a little bit down, let's say 100. We'll make it the same size as the other one, so they're uniform. Okay, now we want to have some text for these buttons so that we know what's happening when you press them. So let's drag in a text on this button and a text on this button. Let's have the first text say retry. And let's have the other one say quit. Compile and save. We probably want to make the game over text a bit larger so it's easier to see. Let's see if we can find font here somewhere. Size 24. Let's try 48. Okay. Click in size to content so it gets a box that's fitting all of the text. Now it's prominent enough that you should be able to see it. Let's put it up a little bit further, minus 250 maybe, so it gets away a bit away from the buttons. So now we have a few buttons, and all of these elements are elements that we only want to see when you have actually lost. So let's start off with putting them as hidden when you have them default. So the button 1 should be visibility hidden, and button 2 should be visibility hidden. Game over should be visibility hidden. Okay, so it will basically look like this for the most part, and then when we lose we show these off so the player can interact with them. Okay, next step is we need to add some logic to the retry and to the quit. So we'll start with the quit and we'll go to the graph. We will have the button 1 marked, and actually let's make better names. Let's have some good behavior made here. So button 1 is the quit button, so we will go up here and rename it the quit button. We will go to button 0 and rename that to the retry button. We'll go back to the graph. We have the quit button. We press on clicked down here for an event for it. So we will get owning player. We will say quit game. That's all for that event. We'll go to the retry button. We'll click on the on-click event. For this one, we're gonna be needing a specific node inside of game mode, which we currently have not made a specific copy of, but if we do a get game mode, just say reset level, we can try that out and see how that works out of the box. So now we have all of the functionality for the buttons. Let's make sure that we have a event to call. So we make a custom event that we can call when the player has lost. Player has lost. And we want this event to be something that we get from our game state as well, because game state is handling this logic right now. So we have a condition here when we say if the player has lost or not. So we will create another event dispatcher. We'll call this player lost. And it doesn't need any inputs. It's fine just telling the player that it has lost. So if the player has less than 0 life or 0 time or equal to 0 time, it has lost, and we will call the player lost event. So anybody who's interested to know if the player has lost can now get that information. So we go back to the HUD, which has already bound an event earlier. We will now bind another event. So we have the game state, and we will type player lost, and we will bind the event. We will clean up the connection a little bit, like so. Then we need to have an event for this. So we made a player lost event here. I'll drag that up just for organization's sake, and we'll drag it over here. So the player has lost. The player wants to have the UI elements shown now. So we'll get the quit button, get the retry button, and we go back to the designer because we need to make our text game over here also a variable to be able to access it. So we'll call this game over text. Compile and save, we go back to the graph, and now we can get our game over text here as well. And now we want to set our visibility for these. We have 3 different of these, so we'll copy paste all of them. Let's see if we can make this a little bit tidier somehow. Maybe if we drag this up here. Like so. Then we'll have the quit button down here. We'll have the retry button over here. We'll have the game text over here. Like so. And they're all set to visible. Okay, so in order to test this now to see if it works, we should probably temporarily at least go to our game state and change our max time remaining to something lower. So something like starting with 3 should be okay, I think. Let's try it out and see what happens. So we start the game. Very little time left. There we go. So we run out of time, we get our game over screen here. But as you might see, there are some things that are problematic here. For one, we can still move around. We should probably disable that somehow. And also we have these buttons, but we don't actually have a mouse cursor to move around with. So we'll change that now. So we go to our HUD again, and we will right click and set show mouse. No. if we get player controller, show mouse cursor, and enable that. We also want to disable movement, so we'll disable inputs, like so. Compile, save, let's try it out. Okay, we have a game over screen. Mouse is still making the camera pan around, and I can still move around with our keys, so we have obviously missed something. We'll go back to troubleshooting. So we'll go back to our HUD and check. Okay. Set UI, set input mode UI only. Now this should restrict us to not be doing anything except for the user interface, and the widget to focus on in this case is self, because we are in the HUD class itself. Compile, save, and let's try again. Okay, I can't move around, everything seems to be working much better. Let's try the quit button. Okay, that seems to work. Let's try again for the reset. Doesn't seem to be working. Let's see if we can find the reason for that. Let's go to the HUD class again. It would seem that the reset level is not quite what we want. It resets things inside of the game state, but we also want to have the whole level fresh, meaning we want to remove all the objects and everything like that. So what we will do is we will call for a get current level name. This will give us the name of the level we're currently playing, and then we can go and open a level, which basically means you load up a map, and for us this means that we're loading up the same map we're currently on. So it's essentially meaning we get a restart. Let's try that and see how that works. Okay, so we click on retry, and it has moved us to a new level. However, I was not able to move again after that. This is most likely due to we have set input mode to UI only. So what we can do is on our event begin play on the character, we can set input mode game only. So that means that when we will be recreating the character in the restarted level, we will set input mode to game only, and get player controller for this one. So this should give us our control back. Let's see how that works out. Retry. I can move around. We can get another game over. Okay, so we seem to be able to restart now. Now, however, if you are currently moving while you end up in a game over mode, you will continue moving in that direction. So now we need to fix that bug. So that is likely related to how we're disabling our inputs here and setting input mode to UI only. We need to stop the character from moving. We can do that by getting owning player pawn, and then we cast this. We could cast it to character, but because the reason we're doing this is because we want to reach our movement component, which exists on all characters. Because I believe there is a stop movement immediately, yes, on this level. And that should make us, after we have lost our controls, we should also stop the character from moving if it currently is. Let's see how this works out. So we're moving, we're still moving. That did not work. We continue the troubleshooting. Let's go back to the HUD. Now something we could do is remove this stop movement immediately, the cast, the owning player pawn, because the controller controls the pawn and we don't actually have use for it anymore because it's a game over and we're gonna reload the level anyway. What we could do is an unpossess. Possessing is the method by which a controller actually takes control over an object in the game world. It's every pawn in the game is called a pawn because they can be possessed by a controller, either a player controller or an AI controller. So by unpossessing, you're basically leaving that pawn to be a lifeless husk without anybody pulling its strings anymore. So this should possibly do it. Let's see how this works out. Moving around, moving. Okay, so our character has lost possession of the pawn. We will retry. We are in a new world and we have possession over a new pawn now. That seems okay. Since our disabling of input didn't work at all, and we had to use an unpossessed to instead get our character to stop moving around, we can cut out this part about the disabling of the movement. And just drag it like so. That should be better then. That is all for part 2. Hope to see you in part 3. Keep on learning. Take care.